Let me see if I can clear a few things up on this. Here's our survey, or our information about the Coke and Pepsi. And the question was, in a given city, survey is made, and then the simple question is, do you prefer Coke or Pepsi? 60% answer Coke, 40% answer Pepsi. So an estimation is that in this city, 60% of people prefer Coke. So the first question asks us, does that mean that 60% of the population of the city prefer Coke? No, it doesn't. All we did was we took a guess of what the city looks like based upon this small sample. So we don't really know for sure whether or not that's true. The only way we know whether or not this is true is if we actually surveyed every single person in the city, which is not cost effective. There's no point in doing that. There's two things that influence whether or not this number right here is correct. One is, how confident do you want to be that this number is right? And two, how much range am I given in terms of, if I were to do this again, I'm not going to get 60%. I'm going to get something close to that one side or the other. How much leeway will you be willing to give me when we calculate this? And when I say will you give me, what I mean is, how much room are we willing to give the statistical software that calculates this? You don't really have to figure all this stuff out. So let's go back to this. If the survey is based on a sample of 100 people with what's called a 90% confidence interval, we can assume that if we were to do that again, we can be 90% sure that somewhere between 52% and 68% of the people would say they preferred Coke. So our mean is 60%, and we can be 90% sure that if we did it again, we'd get somewhere between 52 and 68% of the people. Now, what does this look like numerically? Well, if we drop down here, let me move these back over. For our original test, sorry, those were fixed when I started this. All right, our original sample, our mean was 60%. That means that 60% of the people said they liked Coke. And we told this software system to be 90% sure and said, okay, if you want me to be 90% sure, that means if we were to do this again, between 52% and 68% of the people said they liked Coke. Fine. Now, if we go back up here, and we told the computer that we want you to be more confident in your answer, and we want you to be more sure about the answer you're given. It can do that. We can tell it, for example, if we increase our confidence level, we need more space in the range. So if we increase this confidence level to 99%, meaning that we want you to be 99% sure that when you do this sample, that what you're telling us is right. It would have to say, I can do that, but you got to give me a wider range. In this case, it'd be 48% to 72%. And when I say this, I never expected y'all to be able to figure this part out. What I want you to be able to do is discuss what is happening with these and what affects these. So in our second one, we still have the same sample size. We still say that 60% of the people like Coke. Now we've told the computer, be 99% sure about what you're telling us. And in response to that, it would say, if you want me to be 99% sure, then what I'm telling you is that if I were to do this over and over again, I'd get somewhere between 48% of the people and 72% of the people like Coke. So now I've taken the same sample with the same mean. I've asked it to be more accurate, and it said, okay, I can be more accurate, but you got to give me a wider range. Now let's go back up here. Let's say if we wanted to make our sample look more like the population, we started with 100 people, what could we do? Obviously, if you want your sample to be better, you need a bigger one. So we can increase this. Let's go back down here to look at these numbers. Let's say now we had 500 people. It could say, yeah, still with 500 people, 60% of the population seems to like Coke. The 90% confidence interval, that means that somewhere between 57 and 62% of the people like Coke. That meaning that if I were to do this again at a 90% confidence interval, this would be what my range was. So you can see one of the things that has happened is we've increased our sample size from here to here. We get the same means, using the same confidence intervals. Now, just by increasing the sample size, we have narrowed the range by which it is saying that this percentage of people would like Coke if we were to do it again and again. That's why sample size makes a difference in terms of how well it represents your population. Now we've narrowed that band. Okay. Now, what do you suppose would happen if we increased our confidence interval to 99%? We said, okay, we've got more people, let's be more accurate. So we roll back down here now with the same number of people, still get the same 60%. Now we told it to be 99% confident in the range that it's going to give us. And it says, okay, in that case, between 52% and 68% of the people like Coke. So just by increasing from 100 to 500, if I increase my confidence level with that by also increasing the number of people in my sample, I get the same range. But this range is much, much more accurate at the 99% confidence level. The point of this is I want you to be able to see how changing confidence intervals and sample sizes makes a difference in terms of how accurate your sample is in representing the population. So be sure to listen to this a couple of times because it is somewhat confusing. You're not expected to figure this part out because the part about the percentages, the computer will tell you. What you put in is the sample size and how confident you want it to be. The computer figures out the mean and the range based upon the parameters that you put into it. So give this a try. Go back to the discussion board and see what you think about it after that. Thanks.